All right, so I thought I would, as I make the key, just make this video for those of you who are interested. We didn't quite finish this question on, what was it, page 65. So for this particular loan, maybe just to reiterate, because I feel like I was rushing a little bit during the lesson. This first example here did not include payments. And the reason why we did not have a future value of 0 is because there are no payments. This amount that you originally borrowed stays as a debt, right? Like you're kind of accumulating interest over the 5-year period, right? It's a 5-year loan. And when it's time to pay it off, right, instead of just paying 10 grand back, you're going to have to pay the 13,382.26. This is a very it's not realistic. I mean, sure, there are some credit cards that allow you to, make purchases without interest, but there will still be payments involved. So very rare, but this is how you would deal with it. So it's almost like an investment scenario. It's almost like you invest 10 grand and you earn 6%, right? So this amount, the 10 grand doesn't go down, just sits there and accumulates interest. So when it's time to pay it off, it's as if the company or the bank that borrowed you the money invested technically, right? They invested and they earned interest. So they're going to get their 10 grand back with the $3,000 and something in interest, right? For B, to figure out the total interest, in this case, you just go future value minus present value, right? You subtract the initial and the final. And so there's a 3,382.26 finance charge. Monthly compounding would obviously cost more interest. That shouldn't surprise you. Then we did an example. We started it at least in class where you had to have a loan that involves payments, right? Regular payments to pay it off, bring it down. So there you could see, right, that our final value, ultimately you wanted 0. We get a loan for 12 grand, you make $350 payments, monthly payments, compounding is monthly, filling everything in, N is 37, right? So because we know that it's years times PY, right? So 3 years times 12, this actually represents months. So we can just take that number and just round it to 37 or turn it into years. There we go. For B is what would be the balance owing, right? And like how much would you be owing after 1 year? So it's balance 12, right? Because we go 1 year times PY. So that's how much you would owe after a year. C, what would be the balance owing on the final payment? And so basically the notion here is that this is technically the total number of payments that will be needed. Monthly payment, that is, right? Could have been bi-weekly, weekly, you name it. In this case, it's monthly because it's 12, right? It's monthly payments, or PY is 12. So what I did is I figured out after 37 payments, there's still, right, the balance after 37 payments, 37 whole payments, then you still have a little bit left. So your last payment, right, this will be, the last payment will be of this much. And I've had enough loans in my life where they actually tell you, like, you'll have, 24 payments of this, and then one more payment, like that last payment will pay off whatever remains afterwards, right? And it's actually on the contract. So that's a little bit of an extra information there. What was the total cost of the loan to Lars? The total cost is that instead of like the interest earned, it's like the interest that you will have paid, the finance charge, okay? So what I did here is, because payments are involved, I will say, well, right, I made 37. You can't use sum of interest because it's not a whole number, right? So we take the number of payments, which is a bit more than 37, we multiply that by 350, and that is how much we paid the bank. Okay, and we subtract what we borrowed in the first place, so that's 975.62 interest charge there. So I kind of explained it. Maybe it was a little slower. Might have been easier to understand this time around. Okay, example 3. Okay, so Susie took out a loan for 19,540. Just so you know, there could be questions that say you buy something and you need to add taxes to it. So you would add taxes to that amount before you go ahead and calculate the payment and stuff like that, okay? So that's your loan to buy a new car. The interest is right there, compounded quarterly, right? That's important. Wants to pay it off in 2 years, monthly payments. How much will the monthly payment be? This is, in my opinion, a classic, right? That's basically often what we want to know. So for A, we will figure out all these values. Okay. So we know that compounding happens quarterly, that payments are monthly. We want the future value to be paid off, right? The payment, we're going to figure that out. Presently, you're getting 19,540, right? Interest is 2.87. And this would be 2 years times PY, that is 24. 24 monthly payments will be is what we're considering, right? Paying it off over 24 months. So we go to our app, we enter everything. And there it is, 838.67, right? 838.67. And it makes sense that it's negative on our calculator because it's that money is leaving you and going to the bank, right? So there you go. B, how much interest is she paying over the time, right? Over time for the loan. So this is total interest, right? You can use this in this scenario. You can use right, interest from first month to the 24th month, right? Like right till the end. So let's figure that out. So that's 588, 10 cents. And the other way is, I already gave you the formula, total interest is N times payment. This is essentially how much you will have paid the bank, right? Minus the present value. And remember, you will always pay them back more than what you started with. That's the only way they make money, right? So you take your payment, 838.67. I should have started with N, but it is what it is. Let's go 838. Let's see, total interest, if we go this minus this, we should technically end up with the same. We're a little off, but that's just because TVM solver uses this payment has more decimals, so it uses all decimals, so that's fine there. Okay, so we got that. If she decided after 16 months to pay it off in one payment, what would she owe? So it's giving you the time in months already, which is kind of a nice thing here. Okay. So we'll just say, hey, like we want to know how much is left to pay it off. So balance after 16 months, we're going to figure that out. months is just 9, right? After 16 months, we still owe 6,637 and 90 cents. Okay, so this is how much she would owe after 16 months. Okay. You could have also figured out, right, interest paid after 16 months, right? That's just an addition. You would use sum of interest 1 to 16. And how do you know? You can just plot 16 in there because the time, right, is in months. You can also see it as we're talking 16 payments, right, or 16 times that this has been calculated, this whole calculation here. So from 1 to 16, we can just leave it at 16. If it had said after 1.5 years, let's say, we would have to go 1.5 times 12 and then put that in here, okay? So be careful with that. Sum of interest, I'm just gonna go and get that. Change the last number to 16. So 516 and 63. Okay, that's just an aside for you to know. Okay. Another example. This is on page 66. You would like to get a car loan for 15 grand. The loan is to be paid back semi-monthly. That's twice a month, right? With an interest rate of 6.3 per compounded semi-monthly as well. If you will pay back the loan over 4 years, then how much will each payment be? How much will you pay in total? How much interest did you end up paying in total? These two are connected. You'll see that. Okay, so for A, future. Okay, so we know that it's compounded semi-monthly, which means it's 24 times a year. And the payments are also semi-monthly, which would mean 24 times a year. You want it, because their payments is going to go down eventually to 0, right? We want to figure out the payment. At the beginning, we get 15 grand, the interest rate being 6.3%, 4 years times 24, right? 4 years times PY. So if it ever asks you the total number of payments, right, this is where you would get that from. But N also gives you the time in years, right, if you just divide it out. So, right, you go 4 times 24, that's 96, right? So this is 96, 6.3 thousand. We're going to figure that out. I'm going to put it 0 for now. Both of these are 24. Here you go. 176.97. That is the semi-monthly payment, each payment. Each semi-monthly payment. Okay. Interest total, you choose how you want to do this. I think I'm going to go 1 to 96. That's 1,988.87. Okay. Total interest. Oh, that is total interest. Sorry, that would be C. My apologies for that. So B, how much did you pay in total? Total paid. This is simply the number of payments times the payment, right? That's basically what it comes down to. sometimes I call this total paid to the bank, right? So 96 payments of 176.97 would be $16,989.12. Right? This will help you figure out the interest paid because it's just right the difference between how much you paid the bank and how much the loan was in the first place, right? That is their profit. That's the difference, right? Or so you could do it this way, or interest would simply be 16,989.12 minus the 15,000. This I get from here, right? And that's 1,989.12, right? If you do it using the formula, it's slightly off, but that's all right. Okay. Again, I could ask you what the balance is after a certain time, various questions that can be thrown at you. They could say, for example, if you changed your payment to be out of $200 a month, okay, how much sooner would you pay it off? Not a month, semi-monthly, right? If you add another $50 every payment, how much sooner will you pay it off, right? Then, you know what, if you're already watching this, I'll probably add it to my booklet anyways. But I will say this. D. Let's make a question here. And you pause it and you try it, right? If you were to add $40 to every payment, how much sooner will you pay off the loan? Let's do that. Let's do that. Pause it right here and then try it. Okay. NIPV future value PY. Okay. So this is all the same here. Okay. The payment is now going to be 176.97 plus 40, which is 216.97. But you got to watch out. This is going to be negative, okay? That's part of your entry right now. Present value is 15,000. Interest is still the same. We're going to figure out N, right? So you go and, sorry. So we make everything. So you basically go negative 176.97 minus 40. It's almost like you're adding negatives, right? So now your payment is that. And we're going to figure out our N. It should be less than 96, right? That's what you would expect. So 76.3871. That's how many payments it would take you, right? You would have about, right? Earlier we had 96 payments, and now you're making about 76. So you're actually saving 20 payments roughly, right? Just if you look at payments itself. So if we go time, how do we want to do this? You know what? I'm going to do this. I'm going to take the 96 and way up there. I'm going to subtract the 76 here. Let's call it 77. We'll round this to about 77 because right now We want to have a full number. If you use a decimal, that would be fine too. 96 minus 77, and then divided by PY, because that's how we get our years. So I just want to figure out what the difference is in payments, how many fewer payments, and then turn that into, so then we'll know what our time savings would be in years. Okay, so 96 minus 77 is 19 over 24. That would be 0.79 years. Okay, you could turn this into months, right? Once you do that, you got your years, you multiply it by 12. So about 9.5 months, right? I would have to be more specific on a question, like what is it? How do you need to state it, right? So we just go times 12, that'd be 9.5 months sooner. Okay, sooner in months, 0.79 or almost 0.8 of a year sooner. So that's how much you will save. What about interest saved? Well, we can't use the sum of interest, but we can definitely figure out interest by going 76.3871 times the payment, which is $216.97, minus the $15,000 loan. Right, so this is $16,000. Since it's going to take you less time, you should expect there to be less interest paid, even though your payment itself is larger, because you're paying it off sooner. So this would be 1,573.71 is the interest paid, right? So savings would be, take the interest from up there, 1989.12 minus 1573.71. That'd be 415.41. So $400 in savings by you making the extra payments, right? That's money that you otherwise would have given the bank. Right now, this is in your pocket. So you paying it off sooner, right? Almost like basically you're saving money that way. Okay. All right, I think this is it. We'll leave the credit cards question, and thank you for watching. Hopefully this helped.